Hello and welcome. In this video, we're going to be looking at multiplying and dividing rational functions. And really the rules for this are the same as what we normally use when we multiply and divide fractions. So normally when we multiply fractions, right, we just take whatever is in the numerator and multiply it together. And then we do the same with our denominator. So in this example, 1 times 3 would give me 3, and 2 times 4 would give me 8. So 1/2 times 3/4 equals 3/8. If I wanted to divide my fractions, we would kind of do the same thing, but we're going to divide the numbers on the top and then divide the numbers on the bottom. But doing it that way can often lead to confusion. So usually what you'll see is instead of just dividing straight across, you will flip the second fraction and then multiply. Because dividing by a fraction is the same as multiplying by its reciprocal. So we would flip the second fraction and then multiply what goes across. And then as with anything in fractions, if it can simplify, we will simplify it. So 4/6 would just reduce down to 2/3. So dividing with variables, of course, is going to work the same way. Basically, if we are given something like this, where it looks like two fractions inside of a big fraction, remember that the big fraction bar is basically a division symbol. So if I was going to work this out, I would probably want to write it like this first, so that I can see how the division is supposed to line up. And then I remember that when I see a division sign, I want to reverse the second fraction and then multiply. So like we said, we'll just multiply across. So 16 times 9 would give me 144. X times 4, we would write as 4x. And then just like in the previous example, we'll simplify the fraction. So if I take 144 divided by 4, it will reduce to 36. So this example is going to work the same way. So the first thing I'm going to do is rewrite it with the division symbol separating the fractions instead of as a complex fraction to make it look a little bit easier to follow. All right, so just like last time, if I see a division sign in the middle, I'm going to flip the second fraction and then change this to multiplication. And then we'll just multiply across. So 25 times x will give me 25x. 5 times x minus 4 will be written like this. Keep in mind that I need to keep the x minus 4 grouped together, which is why I put the parentheses the way that I did. So then from here, we will reduce the fraction. So I notice I see 25 over 5. So to simplify, I'll do 25 divided by 5 to get 5. Since there's nothing else on the bottom of the fraction, now I can kind of get rid of these parentheses. And then I am done. So the final answer to this one is 5x over x minus 4. I want you to be careful about simplifying this any further. Even though I see an x in both the top and the bottom, because there is a minus sign between the x and the 4, I need to treat the x minus 4 as its own separate thing. So x minus 4 does not cancel out x. Only x minus 4 and x minus 4 would cancel out. So if I had something that matched in parentheses on the top and bottom, I can reduce it. Here, I don't have that, so I'm just going to leave it the way that it is. So looking at this example right here, I noticed that it's multiplication in the middle, so that means I don't need to flip any of the fractions. At the same time, if I want to simplify this, I'm going to want to break down the pieces of the fraction into factors to see if there's anything that I can cancel out in order to reduce these fractions. So when I look at the numerator of the first fraction, I notice both the 7x and the 21 can divide by 7. So I'm going to start by using a greatest common factor to simplify that. So thinking back to what we said previously, if I can factor out the 7, then whatever's left over goes on top. So 7x divided by 7 would just give me an x. And then 21 divided by 7 would just give me a 3. So I need a minus 3 up there, which means my factored form is 7 times x minus 3. So now I want to look at the denominator of the first fraction. And I'm going to use my box method to factor this. So once again, we want to split the 6x up into something that would multiply to negative 27. So if I'm thinking of things that could multiply to 27, I know 9 times 3 is the first thing that comes to my head. So if I make this a positive 9x and a minus 3x, 9 and 3 would give me 27, and then 9x minus 3x would give me 6x. So that's how I'm going to break this up when I put my numbers in the box. So then when we factor everything out, we can take an x from the top row. We need a minus 3 here and a plus 9 here. So my factored form for the denominator of that would be x plus 9 and then x minus 3. All right, so now let's do the same thing for the numerator of the top of the second fraction. So we're going to take the plus 10x in the middle and split it into something that multiplies to 9. So of course, 9 times 1 will multiply to 9. So I want a 9x and a 1x in the middle. And then of course, we'll factor everything the same way. So x comes out of the top row, which puts another x here, which means I need a 1 here and a 9 here. So the top of that fraction will factor to x plus 1 times x plus 9. So our factored form of the fractions looks just like this. So now what we're going to do is look for any matching factors that we can reduce out. So basically, anything that appears in both the top and bottom of a fraction will cancel out when I do my simplification. So these x minus 3s can go away, as well as the x plus 9s. Notice the 7 does not repeat, the x plus 1 does not repeat, and the 9x does not repeat. So after I've done all of my simplifying, my final answer is going to look like this. So I have 7 times x plus 1 over 9x, which if I needed to, I could also rewrite as 7x plus 7 over 9x by distributing the 7. Either answer is correct. You just need to pay attention to the formatting of the way that the answers are supposed to be printed on whatever it is that you are working on. So in this example, we said that division sign means I need to flip my fractions. So I'm going to rewrite it with 5x plus 20 on top and 5x minus 40 on the bottom. And then I'm going to change this and then pretend that it says multiply. And so from here, we're basically going to do the exact same thing. So I'm going to factor all of my pieces, and then cross out any factors that match in the top and bottom of each fraction. So for the denominator over here, I want to split the negative 6x into something that will multiply to 5. So I know I can do negative 5x and then negative 1x, because negative 5 times negative 1 will give me positive 5. And then over here, both of these factors have 5 as the greatest common factor. So I'm going to rewrite each of those in factored form. And so after all my factoring, the denominator of the first fraction becomes x minus 5 times x minus 1. And then the two portions of the second fraction become 5 times x plus 4 and 5 times x minus 8, respectively. So since I've got everything in factored form, I can now go in and try to reduce my fractions. So remember that we said when you see an x and a number with a plus or minus sign in between, we want to make sure that those stay grouped together. So if I want to get rid of this x minus 8, I need another x minus 8 on the bottom somewhere. So this x minus 8 and this x minus 8 go away. On the second fraction, I notice I see a 5 that repeats, so I can divide that out. I know when I divide something by itself, it always gives me 1. So since I don't see anything left in the top of that first fraction, I'm just going to imagine that there's a 1 there just in case I need it. And then looking over everything that's left, the x minus 1, the x minus 5, and the x plus 4 do not repeat. So that's what's left over for my final answer. So I will have x plus 4 times 1 with x minus 1 times x minus 5 on the bottom. And of course, multiplying by 1 doesn't change my answer. So this 1 over here is just extra. So the simplified version of this answer is x plus 4 over x minus 1 times x minus 5. All right, that's all I have for this one. I will see you guys next time.